Okay, so let's think about a way to write out the is prime function. So here, I'll give you guys like a few minutes. But basically, the idea is that try to divide the numbers starting from, let's say, 2 all the way up to n over 2. But of course, n may be even, maybe odd, right? Then you should think about a way to handle that. And there's a test is prime as a function, so you probably don't want to care about whether 0 or 1 are primes or not. If you want to return true, that's totally fine. But basically, you would need to print a few lines whether you have primes or not. Okay. All right, so let's quickly take a look in case if you need some clues. And I was thinking because the context may be a little bit misleading. So I was thinking, okay, how to do it recursively. Actually, it's not that straightforward. So just wrote a loop. So the thing is kind of so let's say if you have a number like 15, right? So you would try dividing by 3 or 5. Okay, you have a whole number in terms of a division, then okay, it's not a prime. But the numbers before 15 being primes doesn't really help you much. So yeah, well, maybe not recursively, but basically whatever implementation that will serve your task, it should be fine. Okay. So if you like to try, then basically what I do here is so here I have the race not implemented error. So what does that give me?
Professor, could you help me understand question? Not understanding the other half of the question.
So sure. What's your question?
So when you say not by recursively checking divisibility, what does, like, can you give an example to?
Oh, basically we talk about recursion, right? So if like for Fibonacci sequence, Fn relies on Fn minus one and Fn minus two. So that's self-referencing. That's the recursion that we were talking about. But here I was thinking for primes, maybe that's not a straightforward way to think about it. So it's basically, I'm just saying, I was thinking about making a recursion, but I hit a wall. So that's so. But yeah, well, if you have any idea that may work, then you can certainly propose. But currently, what my implementation here is just saying, okay, I divide the numbers less than n over two, and if there's any perfect division with no remainder, then it's not a prime. So that's the philosophy of the current implementation here. So so I'm hiding the raise not implemented error. Okay. So so here the top two lines are from the original code cell. That's basically saying here I is 2 by default. So if n is less than 4, you just by default return true. So for 0, 1, 2, and 3. Okay, so of course 2 and 3 are primes. So let's just assume that 0 and 1 are primes also. But then for numbers larger than n, excuse me, for numbers larger than 3, right? So in that case, n over 2 is at least I, right? So you will be able to write out the loop. So I start dividing I all the way up to n over 2. And here I'm using double uh, slash forward slash because I do need a whole number, right, in the range. Okay, and then I just divide. Okay, if n now divides j, gives me a whole number, then it tells you okay, it's not a prime, so it's divisible by that j value. Then the default uh, p, the temporary Boolean expression that I store. So this is a trick that you can always think about implementing. So you want to return p, and you by default to give it a true. And whenever you have a division that carries through, then you switch to a false, and then it will always be false starting from that point. Well, if you want to break the loop, that's also an option, but yeah, it may help. It may reduce the computation, but that's not required. But anyways, and just return p. Okay, so just return that boolean that you stored. And so let's try testing.
plus one?
Oh, a very good question. So why do we plus one? So here I try to make sure that it divides this whole number. Because remember, when you have a range from A to B, you're starting from the number A all the way up to B minus one. So you are not having a B in the at the end of the this list. So that's unfortunate. So here, if you want to make sure that you're dividing n over 2 as that j, then you want to include that number there. So that's the one that I added. Um, well, does it change anything? I'm not 100% sure. Maybe, but
Exactly the composite, like, it's exactly the fact.
let me think. Let's try 4, right? So when n equals 4, you want to divide by 2. So I here is 2, so that's fine. But then n over 2 as a whole number is actually 2. So you do want to divide by 2. So you want to include that 2 at the end.
It's too much. Like,
But if you have, so yeah, let's try that. So start with 2, right? Ends with 2. So uh what happens? So let me store this. Store this. And let me add a code cell. So test is prime 5. Now everything is prime. So there is indeed a problem. There's indeed an issue there. So what's the problem here? So 5. So 5 over 2, right? 5 over 2 with the whole number is a 2. So it actually doesn't test anything.
it's rounds down.
Runs down. So it's the quotient.
So like typically I would think that it would wrap up to 3 and then it would test 2 and 3 separate.
Um
Or like it would test.
so let me So yeah, everything is true here. So I think this thing doesn't change. So let me do that. So it's false that 4 is a prime. Okay, so I need that. So 4 is not a prime. You want to test 2 as a division, and okay, 4 divides 2. So you would want the p to pop to be false.
So, but if I is 2, the code, since you're starting at I is 2, said that 4 was prime without the plus 1, but the n double divide 2 is, I thought, independent of I.
Mm,
Like I thought it would test 2 no matter what, because you're starting at I equals 2.
right. So that's default. Yes. If you want to change I, then you would call here something like 3, but that certainly would break things, right? But if you change that, then let's try 15. So it definitely would make things ugly. It will tell you yeah, 4 is a prime.
I is 2, but then you have n double divide 2 is your range from I to n double divide 2 with plus 1. It was coming up that 4 was still prime, but it would have tested that 4 is divisible by 2 by I being 2, and it should have come with this false.
So
Shouldn't have mattered that. It would have made it be false. I thought.
so now I is 3. So here, unfortunately, that changes that to be 3. So that's
I can talk about I is 2, but you don't have that plus 1 at the end.
okay.
Then shouldn't 4, and like if you test prime 5, then when 4 was coming up as being prime.
You're saying this one is removed?
Like if you do the test is prime for 5, you get that 4 is prime.
Uh, because in that case, nothing is tested.
Y is 2. You start with 2.
The range from 2 to 2 is nothing. The range from 2 to 2 is starting at 2 but ending at 2 minus 1.
Oh,
So unfortunately, there's nothing in the list. So you didn't test. So it doesn't pop false at all. Okay, so this is very important that you, if you want to include that endpoint, you must add a 1 there. Right? Yeah, so let me also write it on the notes. Um, oh, what's the range? Yeah, let me put it at the end. Okay, so like right here, just recall range, start, stop, step here. So the sequence is start, start plus 1 times step all the way until you have start plus k times step, and everything needs to be less than stop. Okay. So basically, that's the stop is where at the point you do not do anything. Okay, so that's unfortunate. So if you have range from A to B, now by default the last entry, the last input step is by default 1, so it's going to be from A all the way to. So yeah, let me add one more element, A plus 1 all the way up to B minus 1. Okay. So if you have 2, 2, then you don't have anything. That's very unfortunate. All right. So yeah, so checking its prime may not be that intuitive to do recursions. Uh, but Oh, and now here we are on the class notebook, right? So let me quickly mention. So in the future, your submissions on Brightspace will be executed, and then I will still utilize Colab to print out your outputs, and then there will be on this side. Okay, they will be on this side. So each one of you have 3 folders. So basically, that homework folder will contain the printouts that I upload, and then I will write things as comments. But currently, there's not much interesting comments except for the star indicating that there are bugs and you need to fix for the current code. So I will not be clicking to to view any of the submissions right now, but basically that's where they are. And also here you see lecture 1 live. Yeah, I can click that. So what I wrote as a preparation for the lectures are actually here. So let's say when I want a function Fahrenheit to Celsius conversion, I would define the function and I want to return the value like this. And then what I do here for the um, interactive input is that, okay, I store that interactive input and then I just plug it into the function. So just as usual. And then if you look at the lines right here, so I have a few ways that are printing a little bit different stuff. So if you print in a string, then the string may have really a long decimal. Then you would say, okay, I wanted to represent 2 decimals. So what do I do? So think about this kind of things as a practice, because in the future, if you're writing your own implementations and if you are asking the code to give you some clear outputs, or clear intermediate steps as printouts, then you would want it to have nice format. Okay, so it's more readable. Okay, so then you can say round to two decimals, or you can use this kind of F string, okay, to only represent two decimals. Okay, so there are many options. But basically, in the future, well, if we don't cover everything, then this is for those earlier no, live coding notes, then I would just share the printouts and make sure to think about. So yeah, we are talking about lecture 4 live coding session right now, right? So for number 3, if there are questions you would like to ask, you can also bring that up. I think the third one is mainly about the linear search, right? So linear search, and there's also what's called the Newton's method or something. So yeah, if you guys would like to do that in class, or if you would like to do this way by me sharing the um, notes that I already established earlier, then either way is fine. So let me think. So let's now come back to here. Oh, that's actually the last question. So let me see. 03. Okay, so there's something wrong with the 4. So let's change that back and test again. So 4 is not a prime, 6 is not a prime as you know. 8, 9, 10, they are not. So that's sufficient, right? Okay, so yeah, let's quickly put it to a vote. Let's say, so for live coding session 3, okay, so then notes. Would you guys like me to go over the questions in class or share the printout on uh, the class notebook? So,
I just don't think that we're
oh,
going to get through everything. Yeah. So I'd rather have the printout for what we don't get through.
yeah, of course, of course. But let's say in today's class, would you guys like me to do that, or just go over the third um live coding notes, or we continue with lecture 5? So put up your hand if you would like to go over the third live coding. Not the majority, unfortunately. So okay.
For lecture third, are you asked?
The third live coding session.
Oh,
All right. So yeah, well, yeah, I'll share it later. Let me think. Assignment problem set 2 is mainly on lectures 3 and 4. So, uh, yeah. Yeah, well, when you're doing the homework, right? Yeah, you guys still have the option to ask me to do certain questions in class because they are indeed related to the problem set too. So I may release it a bit later, okay, but not probably not today. So, okay, that's lecture 4. That's lecture 4. Okay, so let's go back to um, lecture 5. More recursion. Strings and lists. So well, some of the material here is actually from another set of material, which is this book right here, the Harvey Mudd book. And actually, this is a website that's also pretty nice, and I think that they have a well-established demonstrations of how the Python interpreter is actually carrying through the computations. So this we will go over in detail in today's class. So basically, your function is to quickly be reminded that a recursive function uh, requires you to somehow refer to itself, okay, possibly to prior cases, okay, of itself, and it makes references to itself. So they are a little bit circular, but not exactly, okay, but it's basically building up on um, itself with slower or but prior inputs, okay. But base case is very important. That's the key. Okay. So it's possible to have one or more. And so in order to save computations, a natural idea is to store a list um, of base cases, and so that you will not have to recompute everything. Okay. So that's something we definitely can do after we have the lists discussed. So factorial revisited. So there are two ideas right here. So one is recursion, one is the loop. So we discussed that before. So you can write the loop by having the numbers that you multiply from 1 all the way down to n. Okay, so every time you just multiply one number, so that's the while loop or for loop that you can establish. Or what you can do here is, okay, every time I have n multiplying by the prior factorial that I recursively define the function. Okay. So that's nothing super new. But now we can visualize this kind of procedures on this website, okay, what's called the pythontutor.com. So this website tells you how the functions and their calls operate, okay, in the end of the interpreter side. So what's very important are what's called the stacks and frames. So basically, these are the ways that the memory of the computer is organized. So basically, whatever, when you think about the execution, right? So you have a function here, a function here. So you need to hit run, right? So when you run, basically these are sequentially being somehow kept in the memory. And then once you hit demo of 15, so basically you're calling a function. Okay. So basically what does it do? Firstly, it will um, define the function g of x. So basically the system knows, okay, I have g of x and I need to be aware of as a function. And then I know, okay, demo is another function. It will not really carefully go through the definition of the functions. But of course, if there are bugs, they will know. But basically here, if you read carefully, what does it do? So g is actually this linear function. Okay. So now for demo, you have what? You have the input dividing by 3, taking the quotient, and then you plug into the function g. Okay. So that's so this is something interesting. So basically, whenever you call the demo function, you would have to call g as an inner function, right? And finally, you return x plus y plus z. So now, when we execute at this point of demo, so at this line, so what does it do? So it tells you, okay, I need to call the function demo. So then these lines will be line by line executed. But then when it hits this second line of the function demo, then you would have to call the function g, okay? And then you would execute the lines of the function g and then return, and then you would be able to go back. And finally, you would return x plus y plus z as the output of the function here. Okay, so then you go back to print. So somehow just show show the output of this function. So this is the way that I would describe, okay, if I were the Python interpreter. But then we're gonna also look at this on this Python tutor.com. So that's So here, yeah, one thing to quickly highlight is that, okay, every call of a function brings a memory to a new frame. Okay. So that's sort of like the way the computer would think. So for us, for intuition, we're just basically saying we're referring to a function and then we are calculating, but we're calculating using our bare hands or our minds, right? But then the computer does it more explicitly using memory. So yeah, so let me share this again. And five, five, five. Okay, here. So let me zoom up a little. Okay, so here, let's firstly quickly introduce what this interface looks like. Okay, so here, the green arrow, which is not shown in this picture, is that basically the green one tells you which line you are currently just executed. The red one indicates, okay, which one is the next one. So if you haven't started yet, then they will about to execute this line, the line one. And then basically you hit next, there will be 12 iterates, okay, 12 lines that will be executed now one by the other. So let's see. So if you hit next, you do notice, okay, so this is the line that's already just executed. Notice it actually skipped 2, 3, and 4, okay? So in on the right hand side, this is basically the frames and the objects. So the frames are the sort of the um, memory that's allocated for a particular thing, okay? And what's that thing? That thing is G, which is a function, that's an object, all right? So now this G is just a function name. So now if you move on, the next line is going to be the fifth line. So do I need to zoom up even further or is it clear? Okay, it's good. So now the next line is actually, okay, I store the function demo. Okay, so now the global frame. So the global frame could be considered like the main function if you are familiar with C++ or a language C. So basically it's um, the global memory. And in contrast, the things happening inside functions, they are the local. Okay, so let's see. So the next line being executed is the actual function call. Okay, so nothing inside the functions are executed. So now let's hit next. So here you see, okay, I have demo. So once that's called, you have another frame. Okay, this is what's called the stack frame. So for the function, it tells you, okay, x value is 15. So basically, it's assigning 15 this value. Well, yeah, but basically the 15 is a number. You assign it to x, okay, for as a local variable, and this is a local frame, okay, the frame for the function. And if you move on, it will now start to execute the lines for the function. Okay, so now I'm gonna do 15 slash 3, and I'll get the value of 5. Okay, so that's what's just executed. That's the local, again, a local variable. Okay, local frame. So now we executed z equals to g of y. So now we call the function g. So for a different function call, we have a different frame. So this is another stack frame. So basically, they are completely separate, as you see. All right. So you do notice here in demo there's x, right? So there's an x variable that's local. It doesn't interfere with this x at all. Okay. So this x is another local variable. That's the argument that you define for the function g, but it just is a local. right? The next thing that you can expect is to, okay, calculate the result and return the result. So let's just look at that. Okay, so, okay, I calculate the result. That's 22 after the calculation. Now I return. So when I return, what does it do? Here, okay, so now the interpreter knows, okay, the value that has to be returned is 22 for the function. So that's in red. So here the return um, syntax, okay, just tells you, okay, um, this frame is gonna collapse and it's gone. All right. And now I have what? I have z value. So g of y, once the computation is done, then that memory is erased in the system. So every local variable is gone. And then you only have the z value 22. So, and then we can move on to return value. So now, once that return is captured, then you would have to collapse this frame. And then finally, I have uh, executed. So what's the output? What? Okay, yeah, right. So, oh, yeah, right. So demo is the function that we are calling. So it will show 42 somewhere if we were in our interfaces. Okay, so that 42 is what was fit uh to our eyes, but that's not displayed here, unfortunately. Yeah, but that's done. Okay, so this is the idea. So the objects are the functions, and then the frames are actually the memory in the system. How the Python interpreter would uh, allocate, okay, assign memory to. Make sense? So yeah, this is a really handy tool for especially when you are starting with understanding the language. So, and we will see a little bit more on these when we move forward. Yes.
We executed the demo 15 and stored access 15. Why did it go to line 5 and do demo x and not g of x? Because it's called demo.
Right. So that's the function g that we call. Excuse me, the function demo that we call. So when you call it, it's basically the global frame knows, okay, that's the function that I want to go to, and then we go to, yeah. So first. So yeah, so let's quickly refresh our memory. So firstly, what does it do? Okay, I have a function. I know, okay, it's a function g. Okay, another function is the function demo. So now I'm calling demo. So I need to refer to the fifth line. Okay, so, and then now I know the x value here, the local value is 15. So I just go through every step. And then once I get to this line that's executed, I know a y value is 5, need to be substituted into g. Okay, so now the g has input x. So now the x value for g is 5. So, and then I execute the g, and then I will collapse this by getting the result of g of y, right? G of 5. And then I set a z. And finally, x, y, and z are utilized for collapsing of the demo function, and then I'm done. Okay. So that's what's happening on the high level.
But x value here.
Oh, x value is already here, right? So yeah, so the local, excuse me, the stack frame. This stack frame here just is the memory associated to the function demo. X is already fed and is memorized. Y is calculated in the sixth line, memorized. Z is calculated through calling G and then stored as 22. And then finally,
for both the first definition and second, right?
so the x's are local variables for each functions. So they would not interfere at all. So let me quickly mention that.
Like you have the indentation is where the axes are. Like if the y equals x double slash 3 was the same indentation as the definition demo x, then it wouldn't be local anymore. It would be global.
Right. That's a correct interpretation, but it will pop you an error because it's expecting.
Right,
Yeah.
but like that's the difference between.
Very good point.
Mobile is like the first, like the headlines.
Very good point. Very good observation. So whatever lines that you have no indentation, that's sort of like the global frame. So yeah, you can try mixing this kind of lines by having no indentation lines up front, and then the function definitions and function definitions or loops, and then with other non-indented lines. But then the non-indented lines are in the global frame, indeed. And then the things that are following the definitions of the functions, or they could have even nested things. Then it will be frames under, so there will be more and more memories being utilized.
And
Yeah.
nesting, are all of the nestings local to the like original
Yeah.
frame? Like if the definition demo, which all of it was indented in, then it would be local to the definition of Gmax.
A very good question. If I define a function,
They would no longer be part of the frame.
let me define a function, let's say fa here within the function here. Then that's local relative to demo, local relative to the global, but not to G. So,
Right.
Yeah. So indeed, but then it will have further indentations, which you may want to avoid because that's not really intuitive when you read the code. Okay. So which is why people would have different kinds of files containing different functions and including them in other files, because otherwise the code would be unreadable. So it will have layers of indentations. So another thing to mention, quickly to mention, is that it's very common to write double for loops. So you have for loop within the function so within the function you have one tab of indentation, right? And now you have for, then under for that's another tab. And then if you have double, then you would the next for is the triple. So it just gets more and more indented. So it's getting less and less intuitive. So those are things that you try to make clear about your nestings or try to avoid that much within one file, right? But yeah, indeed, the no indentation would be mostly on the global frame. That's a very good observation. And then the locals are indeed for the functions with further indentations. Yeah.
Definition demo
Mhm.
within the first definition G of X.
Mhm.
Then the X I define at the top will be used for the demo X, because now the demo X is within the definition of G of X.
You may want to try to avoid repetitive variables within one particular cell. Within one particular thing. So remember that example we did in class in the quiz, right? So you have h value somehow specified earlier, but when you have the function return, that value is utilized in the output of that function there. So let me see if I can quickly. So if you're nesting, then you would want to avoid using repetitive variables to avoid that kind of stuff. So quiz, not quiz. Here, right? So that's so if you use an m that's repetitive, that will be callable inside the function. So you would try to avoid such things. So even notice even you don't use m as an input, but now it's referred as something callable within the stack frame. All right. Okay. So even when you do not have this as a level of some necessity function. Okay. So even if that's the thing, then the global variable is now callable within the functions. So yeah. So if you stack another function within a certain function, then try to avoid unnecessary repetition of variables. A very good observation. That was a good. Okay, so now let's see. We are lecture 5. Yeah, so this is the visualization of okay, visualization of recursion. Let's quickly look at that. So let me close this. Okay, so we have two different versions of factorial. Okay, so let's see how they behave differently. They are essentially doing the same thing. Okay, so here we are doing the loop. This is the natural one. So we're multiplying 1 all the way through 4. Okay, so there's nothing really special here. But remember, the first step is to get the function name, sort of. Okay, that's the object. That's a function. So whenever you have definition as a function, we have the function with the variable n right there. Okay. The next one, okay, we call the function with the input 4. So that tells you, okay, the n local variable is 4 as assigned. Okay. And then we just go through, okay, total equals 1, j equals 1. So now these are the local variables being stored. And then I have the while. So yeah, we have a while loop. Okay. So j starts with 1. And once the arrows hit to the end of the while, only these two lines, okay? Once it hits to the end, then j will increase. So this is changing dynamically, okay? So now j is 2 now, right? So and then the total would multiply 2, so which becomes 2. And then we update j equal to become 3. And then the next one, yeah, so every time it's checking whether while is true or not. So now here we have j equal to 3, which is less than or equal to 4, okay? And then total is going to be total minus multiplying by j, which is 2 times 3 is 6. And then I need to update j again. And then now I check again, okay, if j is less than or equal to n again, okay, it's still true. So I continue with while, and then I multiply. That will give me 24. That's the total. And then I update j to be 5. Okay. And when j is 5, now the while is skipped because now this is a false boolean. All right. So this is something you probably haven't thought about, but definitely if you are doing this kind of demonstration, it's clear. Okay, what's your end j value? It's actually 5, which is the one that's beyond the n value. Okay, within the while loop. So and then you just return total. Okay, so here return once it hits here's return tells you okay. I need to return the total as the output value, and then this stack frame would collapse, and I'm done. All right. So here it shows what? It shows 20 steps. So at the end, so of course, when you try to do this kind of demonstration, make sure that your code would not run too long. So if it were over 1,000, then they will not execute. But if it's a few hundred, then it's still doable on the website. Okay, so far so good. So while loop is pretty straightforward. Okay, so let's quickly look at the recursion. So now the recursion has what? It has 7 lines, a little bit shorter code. So let's see how it would behave. So okay, stores the function factorial. Knowing that the object here is a function that has a variable n, And then still factorial n is 4. So now, notice, okay, so here n equals 4. We go to the next line is the if statement. It's neither 0 nor 1, so we actually go to else. So, right, so we execute this line. It's false for both, so we go to the else. And then the next line to be executed is the return. So now when we have return, we have what? We have 4 times factorial 3, which is calling factorial. So I have another frame. So now factorial 3, so I'm calling this again. So here I once again go through 2. If 2 is true, then I just go line 3. If not, then go line 5, right? So line 5 again. So now I need what? N 3 times factorial 2. Okay, so I'm calling factorial again. And this is exactly what the recursion. So you notice it requires a little bit more memory, right? So your factorial 4 relies on factorial 3, which further relies on factorial 2, and then 1, and 1 is the base case. So once you get to factorial 1, then you are able to collapse, and you can return 1. So okay. So now that returns 1. So once that's returned, you can go back to what's pending over there, and then all the way up. Okay, so you remember here n is 2. Remember here n is 2. Your collapsion well is 1, so that's returning a 2. And then later here factorial 3 is waiting for 3 times factorial 2, so that's waiting on that value. So that's a 6. Okay, so this 6 will be multiplied here because factorial 4 is waiting on what? 4 times factorial 3, which is this number. So this is 1 by 1 collapsing. So this is the a different implementation that requires 18 steps comparing to the loop. All right. So that's good. So now, based on the nature, you may want to play with the Fibonacci sequence on here to see what kind of reliance this is on. So now we have one factorial relies on the prior 1 factorial, right? But if you have Fibonacci, then at let's say f of 4, then it would pop up 2. But then would it simultaneously pop up, or would it do pop up f of 3, and then f of 3 relies on f of 2, f2 relies on f of 1? Would it be a different sequence? That's something you can try to explore. Okay, and this is not straightforward. Okay, not at all straightforward. But the way people think may be a little bit different from the way that computer will think. Okay. All right. So let's let me see. Okay, so yeah, we at the moment can stop with this demonstration for now. So now let's quickly look at some of the operations on strings. Okay, this is very important. So here, we were talking about the functions with numbers, right? But here there are applications to strings as an object as well. So the length of strings is a very important function, len of s, okay, which returns the length of the string. And of course, if you have len of an empty string, it's just going to give you a 0. And one thing to also mention is that we mentioned earlier also that this is actually the length of a list. So when you have a input as a list, len will also give you the length. So also we mentioned in the live coding of lecture 4 that we have this kind of referencing of elements. So s of I, okay, returns the character in the ith position. Okay. But remember, I here actually goes from 0 all the way down to length of s minus 1. That's the nature of the indexing. So it starts from 0. Okay, so if you have a length of 2, so it's gonna be 0, 1, and done. All right. So here, so this is the design of this node is a quick pop quiz. Why does s of length of s return an error? And what kind of error would it give you? So let's quickly take a look at that on the notebook. We are here. So that's my string. So length of s will get you how many characters are there, including space. And if you are looking at s of 1, so you are expecting not the first element, but actually the second, because the first element is indexed with 0. So you notice we are not getting m, but we are getting y, right? So this is very important here. So now let's get rid of this pound and see what happens. The string index out of range. Okay, so too large. So the length of the string is 10. So your indices are from 0 all the way up to 9. Okay, so 10 here is not a legal input for my string location. Okay, that's what's happening here. All right, so these are the things that we mentioned earlier. So it's really similar to the range. Okay, S with square brackets, I colon j. So basically, it's starting from ith index. Well, so starting from index I. Okay, so that's more correct. So I in English it means something different. So the first means first, but the index j first is actually index 0. So just be careful. So the index 0, index I will be included, but index j is not. Okay, so just like range. So it starts from I ending at j minus 1. Okay, that's just ignoring the things before I, ignoring the things after, starting from j. So that's slicing. And if you say, okay, I want starting from I all the way, so then I can ignore, okay, just give a space there. So it's just to get a default ending, which is the end of the string. And similarly, if I would want everything up to the j minus 1 index, then I would do a colon j. Okay, nothing for the start. All right. So let's try this. So this gives you what? This gives you from 0 to 6. This is a length of 6 string. Okay, so 1, 2, 3, 4, 5, 6. The space is included as the third character, but index 2. All right. So let's play with this one. So now you are starting with index 1 through 6. That's actually what? That's actually the second character, the third, the fourth, the fifth. Wait. And 5 is 6. Yeah, the 6. So you may want to only use index with following the number to indicate where it is, because think about uh, um, whether it's the first or the sixth is a conversion you have to do. Yes.
If I can allocate or ask Python to consider the first character not as the 0th position, but the first position. Start from 1 and not from 0.
by nature of Python, the indexing is always from 0. So there may be some way, but you have to specify, not in a straightforward manner.
Like if I can specify it before writing the code, so I don't have to do n-1 all the time.
Right.
That would be something-
Unfortunately, I don't have an answer for that.
Okay. Yeah.
Unfortunately, I don't have an answer for that. So my suggestion here is that try to adapt to the mindset that whenever you have a value 1, that actually means counting from 0. Yeah, so yeah, well, not um obvious at all. Okay. So let me copy this to quickly reference. So this is from the index 1 all the way up to index 5, 2, 3, 4, 5. All right, so like that. And then if I start with 6, that's gonna be, you see they're not overlapping. Okay, so with the ending 6 and with the starting 6, they actually do not overlap at all. So why not we do print? Yeah, I'll probably display them all at the same time. So that okay. So from the index 1 all the way up to index 6, excuse me, index 5. 1, 2, 3, 4, 5 is that, which is here, right here. Okay. And you notice that starting from index 6, let me zoom up in case you need to see it. So starting from index 6 is actually everything that's not highlighted and beyond. So RONA. So that's basically everything afterwards. And when you talk about the index 6, that's actually this place. 0, 1, 2, 3, 4, 5, 6. That's R right there. And if you're looking at colon 6, okay, omitting the first input, okay, so that's basically saying everything up to the index 5, okay, 0, 1, 2, 3, 4, 5, still this, okay. So here notice that 0 here doesn't really play much, make much difference.
And if I want to, I don't want the spacing to be considered within the indexing. I only want the Python to index the letters and not the spacing.
A very good question. So how can we do this? One thing I can tell you is that you can replace the space with, you need to modify the string a little. So basically, since in Python, it doesn't consider space as something different from other characters. So what you can do is remove the space and then think about the labeling. So modifying that.
I have a mixture of alphabets and numbers, and I want Python to index only the numbers. Will it be able to pick certain?
Then okay, if you're saying you have a long string, right, mixture of characters and numbers, and you would only want the indices of the numbers, then there's a small program that you can write. That's exactly your programming skill would be utilized. So this is sort of the data processing, right? Pre-processing. And of course, you can also check online to see if there are already established packages and functions, which possibly could there could be some. Yeah. So there are many string operations that can be utilized. So let me quickly point that to you. So okay, so this is a reverse of the string. So we can quickly go back. So here you see there's a function which is called replace. So this is very important manipulation of the string. Basically, we are looking at what? We are looking at a function that's not called in traditional way. So it's what? It's calling an object followed by a dot, and then the method we want to apply to the object. So let's say we have a string s. You do s dot lower with the brackets. That will make all the characters lowercase. If you want to do replace, what do? You do that string s dot replace that quotation of space, and then period, and then quotation of nothing. So that removes the string. So let me quickly do that to show what's actually going on. Okay, so that's the thing that you just mentioned. So let's try print. Wait, probably not straight that directly. So s dot replace replace space with nothing. Wait. And then I print s. So let's see what that happens. Oh, okay, so wait, what? Let's try this. Did I do something wrong?
The first line of that code is the pound. To leave the s equals by trying to not be made common.
Oh, yeah, it's commented out.
It's stored it's called earlier, so it's right here. Yeah. Let me quickly see what's going on. So let's try that. Something is not working properly, but I don't know what. So s dot upper. So let's try that. What would happen is that wait.
Are you calling s somewhere again?
What? Yeah, let me copy that. I don't think I did something unexpected, but what? Upper. I didn't spell it wrong. Print s and weird. There's probably some function. Oh, there's probably something wrong with the function. Yeah, right. What about lower? What about this? So probably it's because of the version.
No, it says that if you tell you what the s types, next it says this will show the original string.
Let me.
So if you hashtag the s in the front as well, and then do the s dot upper, it will do all other things. I don't know why, when you recall just s, it doesn't do it anymore, but that's what your note says.
Right. But
Why it does that. That's
but well, one thing I'm pretty sure is that there are certain operations like this, following with dots, the dot and then the operation would directly manipulate the string or the list itself. So for these strings, probably they do not do it directly, but they're just like what we see right here. Okay, so this fortunately it will not directly rewrite the original string. So you have upper that's yeah getting you the upper cases, and then when you display as yeah so yeah I think I made my confuse myself a little.
Reassigning.
Um, yeah, I was trying to be careful for because
Then it will print it offer.
yeah, okay, very good. So let me quickly do that. So this is fortunate because there are certain operations that will directly rewrite your data. Okay, so here fortunately we don't have that. Okay, good. So yeah, so let's quickly print that replace. Yeah, so the thing here is that when I do that, so okay, it does something, but it just doesn't display directly. Okay, so yeah. Okay, fortunate. So very fortunate that for strings, for these operations, you will not overwrite your original data. Okay, but it will behave a little bit differently if you have some other functions. So let me okay, we have a few minutes. So let me quickly point to you what could go wrong. Okay, right here. So the lists. Um, there's an operation. Let me quickly mention that. So append is to just append an element to the end of your string, your list. Okay, so so these lines you can read through and basically see what happens. So you have statistics, algebra, topologies, statistics as a list, enclosed by square brackets. When you do append, your data is rewritten. Okay, so okay, so this is probably the reason why in my mind I was thinking don't do that to a string. But okay, string is a little bit different. But now here, when you do append, then your string is actually including analysis at the end. Okay. And if you want to insert complex analysis, this is at what? At the one place. So that's actually the second entry. So it's going to be right here. All right. And let me quickly mention there's a pop. Pop, where's the pop? Also, but here, just be aware for lists, these kind of operations can modify the original data. So if you ever want to store the original data to not change it by mistake, to keep a copy, then think about the way that try to search on the internet and see how can you do that in Python. So probably the answer is not directly assigning your data as to some other variable, let's say t. Probably that's not that straightforward. Okay, so try to search and we'll continue next time.